Alright guys, some more examples to use this Cauchy integral formula. Let's start with first example, but there is a remark which you know that formula for cos of theta in terms of exponents, which is e the power iota theta plus e the power minus iota theta over 2, and for sine theta it is e the power iota theta minus e the power minus iota theta over 2 iota. Now the first example, if t is pointwise real number and your circle is mod z is equal to 3, we have to show 1 over 2 pi iota integral e the power tz over z square plus 1 whole square dz equal to 1 by 2 sine of t minus t cos of t. Nothing to do this, just you have to first split the denominator. We know that z square plus 1 can be written as z plus iota into z minus iota whole square. So I have splitted this in parts, and then 1 by 2 iota, take the square of this, which is minus 1 by 4 because iota square is minus 1. And then if the first 1 over z minus iota be your a and 1 over z plus iota be your b, then a minus b whole square is what? That is a square plus b square minus twice a into b. That is what I have done. Then just open this. First term, second term, third term is again split it into two parts. And then finally I will be getting this 4 terms. Now our integral will be equal to this, and for the first term, iota. Does iota lies inside the circle? Yes, because our circle is mod z is equal to 3. So iota lies inside, so here fz will be e the power tz. For the second term, minus iota also lies inside, so fz will be e the power tz. And so on for the third and the fourth term. So writing fz to be equal to e the power tz, we need f dash z because for the first and second term we will use Cauchy's integral formula, and for the rest of the terms Cauchy's first integral formula. So we need f dash z, that is t e the power tz. What is f dash iota? That is iota e the power iota, sorry, this is, we have to put instead of z. So taking z is equal to iota, we have t e the power iota t. Fine. Now since fz is analytic inside and on C, and the points z equal to plus minus iota that lies inside C, so this expression is equal to, using Cauchy's integral formula, for the first term we will be having minus 1 by 4 2 pi iota f dash iota over 1 factorial. Then for the second term also 2 pi iota over 1 factorial f dash minus iota plus 2 pi iota, and here iota is also present. So iota into iota, I have written iota square f of iota minus again 2 pi iota into iota is 2 pi iota square f of minus iota. Alright, this is equal to minus 1 by 4, taking 2 pi iota commonly outside. So this is 2 pi iota inside. What is f dash iota? This is t e the power iota t. And then what is f dash minus iota? This will be t e the power minus iota t. And then what is f of iota? Plus f of iota will be, put iota in fz. So this is e the power iota t minus iota into f of minus iota will be e the power minus iota t, closing the bracket. So if we collect first two terms and the last two terms, we have to make the formula for cos of t and sin of t. So taking t common in the first two terms and iota common in the last two terms, we will get, which is equal to minus pi iota over 2 and t into e the power iota t plus e the power minus iota t plus, taking iota also common, e the power iota t minus e the power minus iota t. Alright, which is further equal to, now we need e the power iota t plus e the power minus iota t over 2. So what we have to do? We have to multiply and divide with 2. So this is minus pi iota by 2 into, if I multiply and divide by 2, I will be getting 2t cos of t. And for this I have to multiply and divide by 2 iota. So this is 2 iota into iota sin of t. Alright. So further, taking 2 common, minus pi iota t cos of t minus sin t y, because iota square is minus 1. So here I'm having 1 over pi iota. I took this pi iota over the other side of the integral, z square plus 1 whole square dz is equal to, taking minus sign inside, sin of t minus t cos of t. We also need 2 here in the denominator. We need 2 pi iota. So just multiply both the side with 1 by 2. So this is 2 pi iota integral over c e the power tz over z square plus 1 whole square dz is equal to sin of t minus t cos of t into 1 by 2. Finish. Next, second example is evaluate integral over c dz over z square plus 4 whole square, and the circle is given to be mod of z minus iota equal to 2. Now in this case, your circle is centered at iota and having the radius 2. So here this is your iota and the radius 2, that means 1, 2 up to 3 iota, and then below iota the 2 radius, that is up to 0 and 0 to minus iota, 1 unit, 2 unit. So circle will be in your green colored form. Alright. Now if we check the points, what is our point? Z square plus 4 whole square. Splitting up, we are having the points plus minus 2 iota. Yes, 2 iota lies inside the circle. But what about minus 2 iota? Minus 2 iota lies outside the circle. It is outside the circle. So I have to take my fz now to be equal to 1 over, because minus 2 iota lies outside the circle, so I have to take this denominator with my fz. So my fz will be 1 over z plus 2 iota whole square. I have to take my fz to be equal to this. The point which lies outside the circle, we have to take the denominator part having that point to be in our fz. Alright. So we have to include this part of the denominator to our fz. Alright? Okay, so let's continue this. This can be written as z plus 2 iota the power minus 2, because we also need f dash z, so that is equal to minus 2 z plus 2 iota the power minus 3, and the value of f dash z at 2 iota is equal to 1 over 32 iota. Okay, because I'm having the power in the denominator as 2 with z minus 2 iota, and I have to use Cauchy's integral formula over here. So since fz is analytic inside and on C, and the point z equal to 2 iota lies inside C, so by Cauchy's integral formula, my integral is equal to this, and what I have taken my fz to be equal to, that is 1 over z plus 2 iota whole square. So this is your fz over z minus 2 iota whole square. So using the Cauchy's integral formula, this will be equal to 2 pi iota over 1 factorial into f dash at z naught equal to 2 iota. Okay, so this is 2 pi iota, and f dash of 2 iota is equal to 1 over 32 iota. Finally it is equal to pi by 16. Next, evaluate this integral where your circle is mod z equal to 2.5. Now see, what are our points? See the denominator. Our points are 1 and 2, and both the points lies inside the circle. Okay, just I have splitted this denominator into 3 terms, and then now my fz will be equal to this. Why? Because all the points lies inside the circle, so no part of the denominator will included in fz. So only your numerator is your fz. Only the numerator is your fz. From that, f dash z is equal to this. Now f dash 1, putting z equal to 1 over here, what I get? 2 pi, and here it will be cos pi, which is minus 1, and sine of pi is 0, so this is minus 2 pi. Then f of 1, putting 1 over here, sine pi is 0 and cos pi is minus 1, and f of 2, putting 2 over here, this is sine of 4 pi, which is again 0, and cos of 4 pi is 1. Now fz is analytic inside and on C, and z equal to plus minus 1, 2 points lies inside the circle. And so by Cauchy's integral formula, we are having this, which is equal to, this is minus 2 pi iota f dash 1 over 1 factorial minus 2 pi iota f of 1 plus 2 pi iota f of 2. Taking 2 pi iota common. Okay, just solve here only. We have taken 2 pi iota common and will be getting minus, what is f dash 1? This is minus 2 pi, so this will be 2 pi minus f of 1 is minus 1, again this will be plus 1, and f of 2 is plus 1. So finally this is equal to 1 plus 1 is 2, take 2 outside, this is 4 pi iota pi plus 1. Next, evaluate this integral where your circle is centered at 4 having the radius 2. So I have drawn this circle which is centered at 4 and having the radius as 2 units. So from this side is up to, this is 0, this is 1, this is 2. Okay, from this side it will be up to 6. So now check the points. If I split the denominator, I will be getting my points to be plus minus 4 and minus iota. Yes, 4 lies inside the circle, but minus 4 is outside the circle, and minus iota is also outside the circle. So only the 4 point lies inside the circle. So I have to take both these denominator, that is z plus 4 and z plus iota, to be included in my fz. So what is my fz now? This is equal to minus, since z is also there, so this is minus z over, why minus z? Because I have taken minus common from the denominator. I take minus outside, so 4 minus z become z minus 4, and 4 plus z is z plus 4. So from here I took minus sign in the numerator. So fz will be minus z over z plus 4 z plus iota. Is it okay? Okay. Next, we need, because the denominators are having only 1 power, so only Cauchy's first integral formula is to be used here. So we need only the value of fz at the point which lies inside the circle, that is f of 4 only. We did not need f dash z. So if you calculate, your f of 4 is equal to minus 1 over 2 4 plus iota. Just solve this. Then, now since the function is analytic inside and the points also lies inside the circle, so by Cauchy's first integral formula we are having this, and because my fz is equal to minus z over 4 plus z and z plus iota, so I can write fz over remaining z minus 4, which is equal to 2 pi iota f of 4, which comes out to be equal to, just solve this, and you will get minus pi by 17 minus 4 pi iota over 17. That's it. Alright, evaluate the integral. Integral is same, but now the points are also same, that is plus minus 4 and minus iota. But all the points now lies inside the circle. Why? Because circle is changed. Mod z is equal to 5, having the radius 5. So minus 4, so plus 4, minus 4 and minus iota. All these points lies inside the circle. Okay, why I'm saying plus 4 and here minus 4, here minus iota? Because we will have 1 over z minus z naught. We always considered this and take the point z naught. So for the first term, z naught is 4. For the second term, z naught is minus 4. For the third term, z naught is minus iota. Therefore, I am saying the point 4, minus 4 and minus iota. All these points lies inside the circle. So you just have to always consider 1 over z minus z naught. So denominator are splitted in 4 terms. You just check, see. First I take z plus iota outside and split these two. And then I multiply z plus iota, 1 over z plus iota inside with them. Again I split these two in 2 terms and this two in 2 terms. Okay? You can just practice, and then I will be having my final integral is equal to this. And now what is my fz? Because in all of the integrals points lie inside the circle, and this minus 4 plus iota minus iota plus 4, these are nothing but constants. So fz is only equal to z. Okay, now what is f of minus iota? This is minus iota. F of iota is iota. F of 4 is 4. F of minus 4 is minus 4. So you just use the Cauchy's integral formula. Put the values of f of minus iota, f of 4, f of minus 4 in this. So just put all these values and solve this. You get their answer is equal to 0. Okay. So here all the points lie inside the circle. Next, there are exercises for you. The first one is, in the first integral, just split this denominator in two parts and you're having a square. A square is given. So plus minus iota lies inside this square. See, x is minus 2 and 2. So from minus 2 to 2 is your, and on the x-axis, and y is minus 2 and 2. So from minus 2 to 2. This blue square is formed now. So this plus minus iota lies already inside the square. So just use now the Cauchy's integral formula and solve this. In the second integral, your circle is mod z is 1.5 and 1 and 2. Your points are 1 and 2. Because the radius is 1.5, so 1 lies inside the circle and 2 lies outside the circle. So take your fz, the whole numerator, including the denominator, as z minus 2 also, because 2 lies outside the circle. So you have to take z minus 2 in your fz. And in the third one, the same example, but here the circle is centered at minus 4. The circle is centered at minus 4 and the radius is 2. Just solve this and you will be getting this answer. So thank you for watching the video. And if you need my new course, Real Analysis, so you can check that course in my description box. So thanks. Next time we will do Taylor series. Goodbye.